It's time for Pure
Performance. Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello to Curse Friday, everybody. It's another episode of Pure Performance with you, and I promise we will keep it clean. We just got all of our sailor language out as we were preparing for this. Andy, how are you doing today?
I'm pretty good, but I'm just laughing that you actually brought this on air. And I guess people are just now wondering why we call it Curse Friday.
Yeah.
It's actually a much better Friday. It's Cinco de Mayo, which is a much better day to celebrate, and we are actually getting ready here in our office in Waltham, Massachusetts for the Cinco de Mayo party, and we already saw the margarita machines, so that's going to be awesome in the afternoon.
Well, you know what? Two more things, right? So a year ago today, we were talking about Cinco de Mayo and how it's really about this little battle that happened in Mexico and had nothing to do with drinking, right? That's just kind of the American bastardized version of it. But a year ago today, Andy, and I know this is being played later on and it's not being played on May 5th on Cinco de Mayo, but as we're recording this a year ago today, our first podcast aired. So happy anniversary to us. Woo! And for our anniversary, we're kicking off a great series that I'm really, really excited about, a great 101 series. So Andy, without further ado, do you want to introduce what our first 101 series is and who our wonderful guest is today?
Yeah. So as you said, we wanted to kick it off with a series of what is a certain technology all about. We call it 101s, and we try to invite experts on topics. Today, it's about what is OpenStack, 101 on OpenStack. And my colleague that has spent a lot of time on OpenStack and is driving our innovation when it comes from Dynatrace, but also working closely with the OpenStack community is Dirk. Dirk, hi.
Hi, Andy. I'm so proud to be part of the anniversary show. I can't tell.
I just realized that as we were starting.
Yeah. So, so Dirk, maybe a couple of words about yourself besides the name, some background and what you do at Dynatrace.
Sure. So I work in the innovation lab at Dynatrace, and my role is called technology lead for OpenStack. So obviously what I do is I do research on the what's going on in the OpenStack communities, and you know that like they're on a 6-month release cadence, so there is a lot of things going on, upstream development, and I'm just following what the technology trends are and like consult with our product management team to provide the best possible monitoring solution for OpenStack that is out there.
Cool. And so maybe to dig right into it, what is OpenStack? Because, you know, it might be a term that people have heard, maybe they confuse it with OpenShift.
Yeah.
But OpenStack, what is OpenStack in very simple terms?
Mm-hmm. So OpenStack is a cloud operating system, and it basically allows you to create your own private cloud in your data center. So you basically take a few servers, install OpenStack on it, and you can launch virtual machines in your own data center as compared to like AWS or Google Cloud. So it's like AWS at home.
Yeah, so that's interesting because a lot of companies, obviously AWS especially is I think the leader right now, but it's also Google, Microsoft, they have their cloud offerings, and many others have cloud offerings. Yeah.
Yes, they do.
And so, but if I don't want to go to the public cloud, but I want to have the convenience of something like infrastructure as service, storage as service, right? All this computer service, then I can just take my physical machines that I have standing around and install OpenStack on it, and then I get the basic feature set of what a cloud is typically offering me. Is this correct?
Exact. That's exactly what it is. So there are like these building blocks that like every cloud service is built of. So there is like a compute service, there's a networking service, and there is a storage service. So all of these building blocks are also making up like AWS and all these public cloud providers. And it's just like the same for OpenStack and your private cloud. So you find all of these building blocks in your private cloud as well. So
I was just seeing all that stuff in Azure as well, all those different blocks that you have. I was just messing around with it too.
So it's basically the same concept for all, let's say, cloud technologies that are out there, let's say on the infrastructure as a service side. And as you were mentioning before, yes, it happens a lot that it gets confused with OpenShift. So the main difference is actually that OpenStack is like the infrastructure as a service, and OpenShift is like the platform on a service. So you can actually run OpenShift on top of OpenStack, and OpenShift would then take care of the applications, while OpenStack actually takes care of like the instances and the virtual machines that are running. So I usually like to compare it, and so OpenStack rhymes with rack, and you usually have the hardware in a rack. So that's like how to easily remember what's the difference.
So now, who is OpenStack? Is this an organization? Is this a company? Can you give it a little bit of detail?
Sure. So OpenStack is basically one of the largest open source projects that is out there right now, with like 30,000 active developers from over 170 countries. So it actually has come a long way since 2010 when it was founded originally. And the governance of OpenStack itself, it being an open source project, is actually done by the OpenStack Foundation, which is like a group of individuals that get funding from the largest companies that are out there in the world. So HP, Red Hat, Cisco, they're all heavily invested. Intel, of course, because they're interested in selling CPUs. They are all investing in this project. And so that is basically who OpenStack is and who's behind OpenStack. And of course...
Go on.
Yeah.
I was going to ask, wasn't NASA behind it originally? Yeah. As well.
Originally, it was founded by NASA and Rackspace in 2010, and it's actually came a long way since now. So it was like this. I think the first OpenStack summit that took place in Austin, it was like 30 or 90 people, and we are actually facing the next OpenStack summit next week in Boston here, and they're expecting like 8,000 people.
Wow.
And it's actually amazing.
So I understand there's companies that are driving the project. It's an open source project. The main consumers, the main users, I would then assume are really either large companies that really have their own data center but want to modernize it, right? Instead of, providing different services, homegrown, home built, I guess they are then using OpenStack. Right, large organizations, And I think in a conversation with earlier, you also talked about telcos. Yeah.
So on the one hand, it's large companies that actually have hardware standing around and just wanna like seize it even more. So make more of the stuff that they already have. Because what OpenStack is actually also about is you have no vendor lock-in. You can use components and hardware from any vendor, so commodity hardware. So. That is cool. And so large companies use it to basically also save costs, because apparently if your environment is large enough, you actually save costs in comparison to public cloud providers. But like the tipping point is somewhere beneath 5,000, 6,000 VMs or so. So it has to be really large. And with regards to the telco business, what they're doing is actually NFV, so network function virtualization, which is actually just applying like the cloud paradigm to telco providers. Like instead of scaling vertically with always bigger and faster hardware, just like scale horizontally with just spinning up 10 additional instances if you need more computing power. That is basically what they're doing.
So Dirk, in terms of, if we go back, several years ago, people were calling private cloud just the idea of running VMware in their infrastructure because it gave them more flexibility and more machines, and it kind of felt like a cloud. But nowadays we see, what cloud is much different. So how would you characterize the difference between OpenStack as a private cloud versus just using, a bunch of virtual machines internally as a private cloud?
So OpenStack, on the one hand, it's an open source project, so you actually could save a lot of money instead of using VMware. Right. On the other hand, as it is an open source project, you can actually ask your developers to develop additional features that you might need on your own, and then you can actually consider committing it upstream and just participating in the OpenStack community. And what you actually also can do, there is like this self-service concept of OpenStack, so you can just create tenants for your business units and assign them a certain quota of resources, so computing power, storage, and stuff like that. And they can actually spin up their virtual machines and instances to their liking. So just they can start instances as they go.
Right.
That is actually,
as opposed to the old way of having to go to ops and say, hey, we need another VM and what size and all that. They can just... No, excellent. Great points.
But to follow up here, so what is VMware doing right now? Are they also doing something with OpenStack, or do they just see it as a competition, or are they participating in the whole open source project?
Well, they are actually doing one thing that is like run OpenStack in VMware, so that's VIO.
Okay.
And I think they're still participating in OpenStack summits and still, but I'm not sure if they're contributing anything upstream.
Okay.
So I don't know that.
Okay, no worries. So, but if we look back at what we said so far, so OpenStack allows me to build my own private cloud with the flexibility of having APIs to span up virtual machines, containers, storage, network. That what I think has been obviously very heavily driven by the public cloud vendors. So developers know the convenience of the public cloud, but if you can't get it, then you can build your private cloud. What is now from obviously from a monitoring perspective, right? We talk about performance and monitoring here. What are some of the things that OpenStack provides itself in terms of monitoring, and what are some of the use cases where we actually said, well, this is not enough, and therefore we build something additionally on top of it? Maybe let's start with what type of monitoring does OpenStack itself provide?
Okay, so there is one specific telemetry project. It previously was called Silometer, which is used to track resource consumption of your instances that are running in your OpenStack cluster. And you could actually use Silometer like for charging your business units. So you've used like 2 days of this instance, so you have to pay that and that amount of money. And you can actually also use Silometer to auto-scale your environment. So there is like this concept of there is a project in OpenStack called Heat, which is like similar to AWS CloudFormation. It actually supports the same template type, so it's really pretty similar. And you could actually like create the feedback loop between Silometer, like the resource consumption model, to Heat to spin up new instances if a certain threshold is reached. Then there is another project that's called Monasca, which is like actually doing collection of more metrics than just like resource utilization. And I think they're also looking forward to integrating log monitoring as well. What else is out there? I think Vitrage is a really interesting project right now because it actually deals with root cause analysis within OpenStack events. Yeah, and then there are like the usual suspects, so Nagios and like this let's call them old school tools for resource utilization monitoring that are also like pretty large still in these OpenStack environments.
And so in all of these projects, I assume expose APIs so we can actually get the data out and allowing vendors like Dynatrace, for instance, to pull data in. Is that what we do, or is there some like underlying OpenStack API that we can tap into and see how many instances are running, what's the utilization, or does this only work in the combination of the projects that you were referring to?
Actually, for our monitoring solution, we have at Dynatrace, you don't need this project because what we actually do is, so maybe steps back. There are like 6 core services in OpenStack, and all of services in OpenStack actually provide an API where you can pull data. So for example, there is the Nova project that is actually takes care of starting and running the virtual machines, and you can like gather data from the Nova API, how many instances are running and when was a new instance started. And that is actually the one thing that we do. We gather data from the computing API, from the storage API, from the networking API to have like the basic information. And in addition to that, we install the Dynatrace One agent on the control hosts and on the compute nodes. So basically really on the bare metal machines. And we're gathering resource utilization data, and like on the control nodes where the services are actually running, we collect also performance data of these OpenStack services to actually have a great overview of everything that is going on in your OpenStack cluster.
And that's obviously useful for OpenStack operators. So these are the people that actually run the quote-unquote private cloud. They need to know how healthy is OpenStack. So we monitor each other. So it's Nova is for compute.
Yeah.
Then storage.
Storage is Cinder. Block storage.
Yeah.
Then Neutron is the networking service. Yeah.
Anything else?
Swift is for object storage.
Yeah.
Yeah. So there's the projects that are mainly used.
Okay, and so that means for operators of OpenStack, it's important to also monitor these components itself, because you want to make sure that OpenStack itself is healthy.
Yeah, right.
That when your developers try to spawn up a new virtual machine, it doesn't take like forever, but actually it's responding fast. So these are good things.
And then you also. Sorry, I was just going to ask, in terms of that combination, do you know if you customers ever see instances where the platforms that they're running within the OpenStack system are being impacted by performance issues on the OpenStack, base components?
Well, so as Andy was saying, when new instances are started, it's usually when errors that happen in the OpenStack control plane. So the control plane is like all of these services that are there happen. Then this is usually impacts most the start of new instances. But what actually can happen in an OpenStack cluster, that is a pretty cool example actually, is the noisy neighbor problem.
Okay.
So imagine you have one compute node where you run several virtual machines on top. So you run several virtual machines on one bare metal machine. So you have limited computing power and processing power. And imagine that one of these virtual machines takes up all of the CPU time. So all of the other instances that run on the same bare metal host actually don't have that much CPU time anymore, and all of the services that run on this affected host will actually degrade in performance. So if that happens, for example, in a public cloud environment, you will just see like a service performance degradation, but you would not even know why. And now with the OpenStack insights we could actually provide, you not only see the service performance degradation, you actually have insights into the cloud platform, and you can really pinpoint actually the root cause why there is a slowdown. So there is because the CPU utilization is so high because of another instance.
But that means it's over-provisioning what happened here. And I would have assumed that something like an OpenShift takes care of that and doesn't allow me to actually consume more resources than are virtually available.
You now said OpenShift, so that is a common mistake.
That's true, yeah, perfect. Thanks for correcting me. So let me rephrase. I would have assumed that OpenStack is smart enough to not allow me to put more virtual machines on a box that doesn't, I shouldn't over-provision, because then I basically run into this issue.
Correct. That is a wrong assumption.
Yeah, okay.
Because the Nova service actually has so it's called overcommit ratio, which actually tells you, so that the default overcommit ratio for Nova Compute is actually 1:16, which in fact tells you for each physical CPU, you can deploy 16 virtual CPUs. And but it's configurable, right? Yeah. So for example, Red Hat OpenStack has set the default setting to 8. So it really depends on your use case, right? Because the assumption actually is that you do not use 100% of the CPU time in each instance all the time, so that it kind of like flattens out in the end.
It's kind of like airplane booking.
As long as we don't have to drag these virtual machines off the physical machine and then hit them hard.
It's called migration, so it happens. It actually does happen.
Yeah. So that's when you actually have you can initiate a migration of one VM obviously to another physical box where more resources are available. Exactly. And is this something that is built into OpenStack, or is it something I need to initiate myself?
I'm not sure if this works automatically, but of course you can trigger it manually. But then again, you would need to know that there are some problems. So that's actually why monitoring is really helpful there.
And I guess that's one of the use cases that I assume obviously support a lot, because we actually see the underlying OpenStack infrastructure, but also the compute nodes and what happens within the compute nodes.
Yes.
And so we can say, hey, we have a microservice that went rogue, and therefore we need to move it away, either kill it or fix it, or move it away to some other area where it's not becoming a noisy neighbor.
Exactly.
I like that term. Noisy neighbor is actually a pretty cool term. Wow. When we were, so we actually spent some time the last couple of days here in Boston at the Red Hat Summit. I know next week is OpenStack Summit, but this week already I took you aside and tried to get some explanation on what we do and some of the use cases. So I think you covered it a little bit, but you mentioned earlier when the number of, or the time increases when you're trying to, you call an API to OpenStack and you're expecting to get a resource, then the health of the system can be defined by how fast they get a response.
Yes.
Right? So this is one of the key metrics that you monitor, right?
Yeah.
Responsiveness of the system itself. Is there anything else from a health monitoring perspective, any key metrics that people should look at and be aware of?
Sure. So with regards to the OpenStack services, we actually are recommending, and it's like there's actually already literature out there that recommends that you look at the availability of your OpenStack services. So are the services up and running? You should definitely look at the performance of these services. So you can just watch if the response time of these services is like increasing. This is usually a pointer that something's wrong. Then, as everyone who knows OpenStack, is that all of these services are heavy loggers. So you should definitely get some log analytics in place, because if you have let's say an 8-node OpenStack cluster with high availability in the control plane, there are at least 100 log files that you need to browse through if something goes wrong. So if you have to do that by hand, it probably takes a long time. And yeah, of course, the resource consumption, not only on the control nodes with the compute services, but also on the compute nodes where the virtual machines are running is important. On the one hand, to identify like the noisy neighbor problem we just covered, but also on the other hand, to get insights into the capacity planning of your instances. So have you really over-provisioned a certain instance? Does it have too little memory or too much storage? And can you like shave off a few gigabytes to save money in the end, actually, to reuse it in another instance? These are actual insights you would need to efficiently operate your OpenStack environment.
I mean, I assume and I know there are obviously software vendors out there that try to solve that problem by shifting things around and or making VMs more efficient in how they distribute them. But it seems we have a lot of great data already, the way we provide. Do we integrate with some of these vendors that are doing automatic shifting resources around, or in case we're not doing it yet, at least we have the APIs, obviously, where we expose all of our data. We could build integrations.
We have no integration as of now, but as you said, we have all of this data. We have an API where actually third-party vendors could pull this data to do some action on that. Yeah, but not yet.
Cool. So to sum it up a little bit, so it's basically I can build my own private cloud. It's about compute as a service, storage as a service, network as a service. I think you also said dictionary as a service. No, what was the other?
It was like object storage.
Object storage, yeah. Cool. Any other terminology that we should be aware of?
There is a lot of terminology, but I think we won't be able to cover this in one podcast.
Okay. And then the reason why I want to ask, there's one thing you actually mentioned this week, and it's the term project.
Yeah. Okay. So OpenStack has actually the possibility to create projects. So we covered that before. So you can create a project on OpenStack for a certain business unit, for example, and you can assign a certain quota of computing resources to that project. And then the business unit can actually spin up their instances as they see fit until they have used up their quota, and then they can request more, obviously. But that's actually is like a certain aspect of OpenStack that covers like the self-service capabilities. And it's actually pretty nice.
Yeah, it's like a tenant system, obviously, right? I would assume. So you mentioned this internal within a big company business units, or like the telco example, you have your customers and they all get a piece of your infrastructure.
Yes. So if you're like a public cloud provider, which is actually one common use case for having OpenStack in place. So let's take T-Systems Germany, for example. There is the Open Telecom Cloud. They're actually running a large private cloud running on OpenStack, but make it a public offering. So like they're creating projects for their customers where they can then make use of the virtual resources that they are providing.
So it sounds like with that approach, then you can take, if you have an organization and you have your development team, your project teams, as you're talking about that, one of the benefits of that is ensuring that your development team doesn't just start spinning up VMs left and right and not paying attention to them, because they'll reach a hard limit before you overwhelm your OpenStack system, because they're walled off into a certain amount of resourcing, right? So if they are not paying attention and not managing their instances well, they'll find out without taking down the entire system.
Yeah, right.
That's really great.
Cool.
Yeah.
Maybe to at the end, I know we talked a lot about what it is, also a little bit already what we do from a Dynatrace perspective. Can you explain in very simple terms how a normal Dynatrace customer that wants to monitor their OpenStack environment, what they do, what they install where, and maybe if there are different options between, maybe, I don't know, if there's an option between full stack monitoring versus just compute node monitoring? What are the different deployment models that we typically see or expect to see?
Okay. Let's focus on OpenStack control plane or OpenStack infrastructure monitoring at first. What you would need to do is install the Dynatrace One agent on the controller nodes and on the compute nodes. And you would, in addition, need to set up the Dynatrace security gateway, because the security gateway actually pulls data from the APIs.
Okay.
And then you would actually need to configure like the endpoint of the Keystone service, actually, because the Keystone service is the authentication project within OpenStack that actually knows all the endpoints of all other services. So this is like the central connection point. And you configure the Keystone endpoint and the credentials, and actually then you're ready to go already. So then you have like insights into what is going on with your OpenStack services. You get the log monitoring of all of these services out of the box. And you also get some insights on what is the resource utilization of your compute nodes. Then if you also want to get insights into the applications that run on top of your compute nodes, you would actually need to install the Dynatrace One agent in those virtual machines. And then you not only get insights into the application, but we also like include the data we get from the One agent from the instance in the OpenStack view to get really detailed information of what's going on with the resources within these instances.
Cool. That's then really full stack monitoring. I mean, this is then perfect. This is like from the bare metal through the service layer into the nodes, into the services, into the apps. Yeah,
it is.
I know. When we go to our Docker support, in order to get insight into the containers, we actually only need to install the Dynatrace One agent on the Docker host, and then we automatically inject. Is there anything like that planned as well for OpenStack, where if you have the One agent installed on the OpenStack infrastructure itself to monitor the OpenStack services, that we can then automatically inject into the compute nodes as well?
Well, no, you need to install the One agent on the compute nodes.
Okay.
But from then on, it's actually launching virtual machines.
Yeah.
And you would like need to know what kind of operating system you would launch within the virtual machine to get the right agent in there. It's a tricky thing.
Yeah.
But there are projects out there in OpenStack that actually do, instead of launching virtual machines, they are launching Docker containers on the compute nodes. And then actually when we can benefit again from our Docker capabilities, because we would automatically be able to inject into those Docker containers as they're starting. And on the other hand, there is also a lot of development going on right now into containerizing the OpenStack control plane. So all of these networking, storage, and computing services, to make it simple, would run in an own container, which make it actually pretty easy for orchestration and restarting services if they fail, and which again makes it also easy for us to monitor and instrument those services again because of our Docker capabilities. So that's what's going on there.
Cool.
Great.
Wow. Brian, anything else that we should cover? Any other questions that came up when you did your research on it? Or are we good?
No, I think we're good. To me, again, with this 101 concepts, what I'm really learning in here from a great level is that it's very easy to think of OpenStack as an AWS. If you understand AWS or Azure, if you have any familiarity with that and all the different components, especially what I saw recently when I was working on some Azure stuff where you have to assign the networking group and the storage group and all these different components. It's not just here's a VM, run it anymore, or here's a machine and just run it. There's much more compartmentalized services that support one another. You're just taking that and bringing it inside. That's, to really think about it in a basic way, OpenStack is your own private AWS or your own private Azure. And with that, then you get the great, wonderful benefit of, obviously there are in AWS and Azure, there are monitoring points you can do. You can monitor your own components, but you can very easily then monitor the entire OpenStack infrastructure, the health of that, the underlying components, so that you understand when there are issues there or issues there that might be impacting your processes that are running up higher. So I think, Dirk, thank you very, very much. It was a great explanation, and it really just kind of cemented it finally for me. And my only other takeaway would be that I think everybody would be much safer calling it OpenS. This way, if you're talking about OpenShift or OpenStack, you're covered.
Cool. Hey, thank you so much, Dirk.
Welcome. It was my pleasure.
Any typically, I guess, Brian, you always ask our guests, but any appearances of you? I know you're speaking next week at the, you spoke this week at the Open at the Red Hat Summit.
Yeah.
Any other things coming up in the summer months where people may be able to see you live?
Well, we're currently planning on hitting the OpenStack APAC event. So I actually submitted some talks to OpenStack days in Japan and China.
Cool.
So maybe there's an appearance, and otherwise there are some events throughout EMEA where they will definitely attend and be present.
Nice.
And if people want to follow you, are you on Twitter where you might be announcing different appearances if people want to keep track of you?
Sure. So my Twitter handle is wall_Dirk. I think we can put it in the description of the.
Will. Yes, we can. Absolutely.
Yeah, and you're also a regular blogger, obviously, on blog.dynatrace.com, so people will find information there. And if people want to know more in general about OpenStack, I believe there's a great openstack.org website where they can find everything. And if they want to find more out about Dynatrace and OpenStack,
they could actually reach out to openstack@dynatrace.com and just ask the question.
That's easy.
It is.
Cool. That ends up in your inbox.
It does.
Perfect. Really cool. OpenStack@dynatrace.com.
I'm going to start using that.
Yeah. Here we go. All right. Well, that's it from me. Thank you.
Thank you, Dirk.
Thank you very much.
Thank you for being on our, well, again, not calendar, but recording day anniversary show. Excellent to have you. And we're going to be having, Andy, do you want to do a little rundown for our listeners of some of the other topics we're going to be covering in the upcoming episodes?
Yeah, sure. Quickly. So we have a couple of technologies that are, new, and we wanted to cover them. So for instance, there will be a one-on-one on OpenShift, on Azure, on AWS, on Cloud Foundry. We will be talking about serverless and Node.js. We will be talking about Visual Complete and Speed Index. So some of these technologies and techniques or frameworks that are out there that are new kind of for the industry, and we just want to get the experts in and get a session like this. So I think I covered those that we at least are on the short list.
Yep.
There might be more coming up.
And if anybody has any ones that they want to hear about specifically, let us know.
Yep.
They can. Where can they contact us, Andy?
Well, I think there are multiple ways. Right, email pureperformance@dynatrace.com is one option. Then on Twitter, it is hopefully I get this right. pure_DT.
Right. I'm putting you on the spot here. That's why I'm doing this.
No, it's good. That's good. And I believe that's the best way. Or they can catch me on @GrabnerAndy. They can catch you @EmperorWilson. And then they should just check out the other podcasts and everything else we do. And I think what I also want to ask Dirk is if we can get you on a performance clinic one of these days, which is a visual web recording where we could show some of the capabilities. That would be nice.
Of course.
Too, yeah?
Let's do it.
Yeah, perfect.
Excellent. Dirk, thank you very much again. I'm forever indebted to you. All right, and I guess we'll be back in a couple weeks with the next 101. Hope you all enjoyed it today. Thank you.
Bye-bye.
Bye-bye.
Bye.